Hey guys, welcome to Safi Mixed. This video will help you to increase your capability of programming with Mathematica as I do programming for a very trivial problem of constructing tables of numbers. So to begin with, you should always add clear all command with argument global to your file because this will help to remove any error if you ironically change the values of certain variables. And then I define a function in the form of two variables, and I just take the product of the two variables. This is a simple function product. Then I construct another function k of variable I in the form of a table, and in the argument I write function f with argument I in j, and then I sum this over from j0 to 10. Okay, this is now a function, and this function, if I run this program, this short program, this function will give me the table of any number you want. For example, if I add 2 to the argument of k, this is now the table of 2. 2 0 are 0, 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, and so on. And if I change the limit of j over here and I take it, let's say 16, then I'll get the table of 2 like this. Similarly, if I change 2 to another number 3, I get the table of 3 up to 16. Changing this limit of the iterator j inside the argument of table would find the values of the table to that limit. And that is one very easy way. I can do things through another way by defining another function g of variable a in a similar manner, but this time I use the for function. And we know the argument of for function, I can write the iterator j start from 0, and then comma, then j lesser than, let me do this for 10, and then I add j by one number repeatedly, and alongside the fourth argument I defined is equal to the function f I and j, and then I ask Mathematica to print the output of s but in a particular format. If I want to find the table of 3, I put a 3 over here, then I enclose x inside the quotes, then comma, then I put j, then quote, then equal to quotes, and then I add s, and I close this, and I define this function. There is a problem of one bracket, so I put that over here. Now I can find the table of any number with this. For example, if I put s is equal to 3 and I do it, it is up to 16, and if I put over here 16, I'll get the table until 16. And I can do this through another way. I want to clear this so that most of the things are visible here. So now I'm defining a blank list in the form of r, that is, I assign the value of the blank list to r, and then I copy this part of the function g and paste that over here, and I keeping all these things same. I just change one thing over here. Instead of the function f, I replace this with 3 cross j, that is, I want to find the table of j, and I change the print command at this position to another command append to, and inside the argument I add or, that is I ask Mathematica to add the value of s to the list or, and since I'm finding this for 3, therefore I convert this to 3 and I put label over here, and at the end I add or and ask Mathematica to show me this in the matrix form. So if I run this program now, it will give me this table, which is the table of 3 up to 16. And I can better be select all. So I watch the value of A and I remove this like I did before. And here is the table up to 16. You can change the value of 3 to 4 to any other integer, and accordingly it will give you the table of that integer. However, if you are changing the value at these two positions, you would need to run the program again right from the beginning, that is selecting all. For example, if I change 3 to 4 and then we're here to 4 and I run it, it carry the value the table of 3 because that has already been added to the memory of 3, and then it add the table of 4. So in order to avoid this difficulty, I just need to press Control A on my keyboard and run the program right from the beginning, and going down it then only enlists the table of 4 in the memory of R. So this way you can write a program either by using the for function or the table function of Mathematica to construct tables of numbers. Thanks for watching.